How would you like to build one of these?
Robot ready.
The robot's ready. That's how Toshiba used the SR4 robot in Japan, as a sort of a show or a showcase robot, with the added twist that this robot could actually be integrated with their equipment, or their equipment could actually be integrated with this robot. The fact that you could take the robot and still using the computer that's on board the robot and the motor wheel assembly and all the basic structures of the robot and so forth, you could add your own electronics to it and make it into something that suited your needs. They thought that they'd want a color different than what we had already on the robot. Hey, that's fine. That's your robot. You do what you wish with it. This is a Polaroid sonar sensor straight out of Polaroid rangefinder cameras, and has the purpose on the robot to detect objects in its path. So it's really an obstacle avoidance technique using sonar. So we have the sonar transducer and we have a sonar circuit here, again originally from Polaroid. On the robot we have a wireless adapter that connects this robot to any home or office network wirelessly and makes it a peripheral to any network it's attached to. Also, with this USB hub, we have multiple USB connections to other devices that can be added to the robot. In this case, we have a wire that goes on down to the voice. So the voice card is actually a USB peripheral to the robot. What we have here is the robot's onboard embedded computer, which essentially runs Linux and Java and database systems. And just above and connected to this board is a 1 gigabyte flash drive that holds all the memory for the robot. This board is called the OOPIC board, the Object-Oriented PIC board, which is a sensor control board for not only the sonar, but if we added proximity sensors to the robot, they would be connected through this robot, or for bumpers and other sensors that you would attach to the robot. The power board for the robot actually draws its power from the 12 volt, 12 amp hour batteries and converts that voltage to either 12 volts or 5 volts that's available to any other devices that you wish to add to the robot. Also on this board is a soft shutdown relay that enables you to shut the robot down and make sure that all the software is cleared out of the CPU before the robot actually physically turns off. And finally, there's a row of connectors on this board that are called I2C connectors that also enable you to connect additional electronic boards to the robot. This is the motor driver board, which is one of two boards that are used to drive and control the motors of the robot. In addition, this motor driver board has amperage meters on it that enable you to monitor the amperage to each motor and thereby determine whether or not the robot's in a jam or is operating smoothly. This is the robot's voice and sound card, which is built on the SpeakJet chip and enables the robot to speak as well as to make a huge variety of sounds. And it ultimately is connected to an amplifier speaker system on board that amplifies that sound. The user panel has 3 power switches, one for electronics, one for motors, and one for an optional arm or other peripherals that we might add to the robot. When the switch is in the up position, the power is on. We have charger receptacles for the charging devices to charge up each of the 3 batteries. Again, the robot originally only comes with 2. We have a serial connector, we have an Ethernet connector for direct connections to computers if that's necessary for testing purposes, although normally the robot, of course, is wireless. We also have a temperature sensor attached to this user panel, and we have 4 programmable buttons that enable you to get into functions of the robot and have data scrolling across the LCD screen.
So not ready.
The robot's ready.